Hello everyone and welcome back to another project. In this project, I'm going to show on how you can design a security system using your iBlinks. So in most of the cases, we design the security system or the door locks using the passwords, the RFIDs, the OTPs, using the facial recognitions or the QR codes. But for this project, I will be designing the secure door lock using the iBlinks. So first of all, I'm going to talk about the feature of my project. Then I'll be talking about the components that I've used here. And finally, I will show the demonstration, the way the project works. So in a virtual zone, if my eye is blinking for 3 times in 5 seconds, then that will be an authorized key. I mean, I have already programmed the authorized key to be three eye blinks for 5 seconds. So if my eye is blinking for 3 times in 5 seconds, that will be an authorized key and the lock will be unlocked. But if my eyes are blinking for more than 3 times or for less than 3 times in 5 seconds, then it will be an unauthorized attempt. So it's a really very smart way to design the security system using the artificial intelligence. And one of the and an important application of counting the eye blinks, I should say. And and the project has 2 parts. One is the computer vision based part and the other is the hardware part. So for the computer vision part, I have written a Python script over there, and I'll be running the Python script on my laptop, but later on I'll be uploading the program onto Raspberry Pi as well. Maybe I'm going to show you in one of the later videos. So right now I'd like to talk about the components that I've used here. So as I've already told you that I'll be using my laptop for running the Python script, and for controlling the hardwares, I will be using the ESP32 board. Now there must be communication between the ESP32 board and the laptop. So I will be using the serial communication for ensuring communication between the laptop and the ESP32 board. But if you want to, then you can also use a local server generated by the ESP32 board for establishing communication, two-way or one-way communication between the ESP32 board and Python. In that case, that would be smarter. I will show that while I'll be designing the computer vision based gesture control bot, like how you can transfer data from Python to your bot without using any kind of wires. I'll show that in a later video. So it comes with a built-in Wi-Fi, but for this part of the project, I won't be requiring any Wi-Fi connectivity. As the electric lock, I have used a 12-volt solenoid electric lock. As for alerting purpose, for triggering the alerts, I have used the 220-volt AC red AC bulb, as you can see. And this 12-volt solenoid electric lock and this 220-volt AC bulb cannot run through the DC control signal, small DC control signal generated by the ESP32 board. So for switching these high voltage loads using the low voltage DC control signals generated by the ESP32 board, I have used this 2-channel 5-volt relay module. So the 2-channel 5-volt relay module is used to switch the high voltage loads using the low voltage DC control signal generated from the ESP32 board. And to power this 2-channel 5-volt relay module, I have used here a pair of batteries that supplies around 8 volts, and it comes with a rated voltage of 5 volts. So the generated voltage by this pair of batteries in series, they have to be stepped down, and I've used the the LM7805 linear voltage regulator. And the output of the linear voltage regulator is 5 volts, which is directly fed to the relay module to power it up. And I have a buzzer, as you can see, that will be buzzing in synchronous to the flashing AC bulb. So that's all about the components that I've used here. Maybe the ESP32 board will not be required when I'll be doing the same thing on Raspberry Pi. So once everything done, I would like to plug in my system, power up the batteries and everything else, plug in the microcontroller. Yes, I have plugged it in. Okay, let me see. Let me plug it in. Yes, I have plugged in everything. Let me reset the ESP32 board. Yes, I have already reset the board. So right now I'm ready to show the demonstration, the way the project works. So let me run the Python script that I've written there. Well, one more thing, maybe I forgot to say that I have a touchpad over here, touch button. You can use it to unlock the door from inside by simply by touching this button. So as you can see that I have a virtual zone. It's counting because when I'm looking downwards, it's considering my eyes to be closed. Whatever, it will be reset as my face is out of this virtual zone. So as my face will be inside this virtual zone, the blink counter will be initiated. And as you can see that I have a live plot on the left that will be showing the distance, the vertical distance between the top and the bottom part of my eyes normalized with respect to the endpoints of my eye. And if it is below a threshold value, then it will be considered as a blink. And there were some conditional logics that I had to develop, like averaging 10 or 5 frames for having a smoother value, like dumping some of the frames for having smoother values, and so on. And the analysis will be performed within this virtual zone. If you're beyond this virtual zone, then nothing will happen. If you're inside this virtual zone, then you can see that we have the blink count available over here. And as I blink my eye, let me get closer a bit. As I blink my eye, as you can see, the counter will increase gradually. So it's already triggering the alerts. Let me reset. I believe you can see I'm blinking my eyes, and as you can see, the counter is also gradually changing. The counter is also gradually changing, and you can see whenever there is a blink, the curve also gets green. So there are some more calibrations that I may have to do, because when I'm getting away from the frame and when I'm coming closer to the frame, or if I'm changing the orientation of my head, I'm getting some kind of ambiguities. I will be working on them, but for now I'm showing this for control environment. I mean, the iBlink project is mainly applicable for control environment, I should say. So let me dive into the demonstration. On top of the left corner, you can see the FPS. That's for understanding if the code is affecting the frame per second that we are getting, if it is affecting the performance. So right now, let's dive into the demonstration. I will blink my eye for 3 times in 5 seconds, and I will show you that the door lock will get unlocked. So let's see what happens. I have blinked my eyes for 3 times. You see that the lock has been unlocked. Now I'll be blinking for more than 3 times and show you what happens. So I'm within the virtual zone again, and I will blink my eyes for more than 3 times for the 5 seconds. Well, the timer will initiate. The timer has already initiated. So it must be unauthorized. You see the red bulb went up, and as I look below, the separation between my eyes decreases and the blink starts counting. The blink counting also goes on. However, as I've already said, this is applicable for a controlled environment. So right now I'll be blinking my eyes for more than 3 times. And one more thing that I wanted to say, the counter initiates with the first blink. The counter initiates with the first blink. I am within the virtual zone. The timer, I should have said the timer won't initiate. The counter and the counter initiates when I am within the virtual zone. If I'm within the virtual zone, and the timer will initiate after the first blink. So it will check the number of total blinks for 5 seconds. If it is 3, then it's authorized key. If it is not 3, it is unauthorized. In case of authorized, the door has been unlocked, as you have already seen. In case of unauthorized, the alerts were triggered, as I've already shown you. So let's show the demonstration for one more time. I am within the virtual zone, so let's blink the eyes for 3 times. 1, 2, 3. You see what happens now? Unlocked. So right now I will be blinking for more than 3 times and show you what happens. So let's see. You see the unauthorized alert was triggered. So let me show that for one more time. I'll blink now for more than 3 times and show you what happens. You see the alert went on. That means it was an unauthorized key. So this is the way the project works. I believe I have been able to clarify myself. And yes, the plot on the counter went on because my eyes were towards the downward direction, so it considered them to be off and a blink, continuous blinks, I should say. So the plot on the left is telling us the distance, as I've already told you, and on the right you can see the live demonstration. I am showing this for one last time. I'll be blinking my eyes for 3 times within 5 seconds and will show you that the lock will get unlocked. So let's see. 1, 2, 3. Sometimes it misses. Unlocked. I believe I have been able to show. So 1, 2, 3. Unlocked. You see. So I will be blinking for 2 times and show you what happens. You see, it was an unauthorized attempt. And as I've already told you, if you want to, then you can also unlock it from inside simply by touching on this button. So let's see what happens. You see, it was unlocked. So let me touch for one more time. You see, it's being unlocked. So you can simply unlock the door from inside simply by touching on this touchpad. So the blink counter is really interesting, you know, as it counts your eye blinks in real time. Let me show you for the last time and then I'll be ending the video. 1, okay, 1, 2, let me reset. 1, 2, 3. Oh, it exceeded 3. Okay, 1. Oh, I have to adjust myself. Yeah, 1. It's lagging, the video is lagging. I'm so sorry about that. 1, 2, 3. Unlocked. Again. 1. Okay. Let me go backward a bit. 1, 2, 3. Yeah, it worked. So that's how the project works. Thanks for watching and stay tuned for the next one. Bye for now.